I'm going to solve this problem 2143. In this problem it is said there three forces act at point O. So these are three forces which act at this point O, and it says that if it is known that the y component of the resultant is minus 5 kilonewton. So if I write that the Ry component is equal to the summation of all forces along y, and this is equal to minus 5 kilonewton, right? This is given. And that the z component is 6 kilonewton, and Rz is equal to summation of all forces along the z axis is equal to 6 kilonewton. This is given, right? So we are asked to find this F3, this theta, and the magnitude of the resultant. So as we can see that we have three forces. This F1 is along the y-axis, right, along the positive y-axis. F2 is along the negative x, and F3 is having some theta with the y-axis. So if we apply the resultant formula, right, so let's suppose if I write that Rx is equal to the summation of all forces along x is equal to, so here in these three forces we have only this F2 in the direction of x. It is in the negative x direction, so I will write the Rx component. The component of the resultant in x direction is minus 7 kilonewton, right? Or we can say that this is minus I, this is in 7I in kilonewton, right? Ry is equal to summation of all forces along y. So if I apply this equation, right, so summation of all forces along y. So now as we can see, this is the positive y-axis. So we have this 4 kilonewton force. So if I write, so this is in the positive y, so I will write 4. And if I resolve this F3 into its components, right, so one component will be from O in this direction, and it will have one another component in this z direction, right? Since this F3 is in the yz plane, right, so it has two components. So this component is the cos component, right? So we will write that this is F3 cos of theta, and this is F3 sine of theta. So we will write 4 minus, this is in the negative y direction, so 4 minus F3 cos of theta, and this is equal to minus 5 kilonewton. It is given, right? So I will write minus 5 kilonewton. So this means that F3 cos of theta is equal to 9 kilonewton, right? So this is, let's say, equation number 1. So now if we apply Rz, which is equal to the summation of all forces along z axis, so this is equal to, so as we can see that this F3 sine of theta is only in the z axis direction, right? So this means that F3 sine of theta, and this is given, this is equal to 6 kilonewton. So I will write 6 kilonewton. This is equation number 2. So now if I divide equation number 2 by 1, so this will be equal to F3 sine of theta divided by F3 cos of theta, and this will be equal to 6 kilonewton divided by 9 kilonewton, and F3 will be cancelled out, and sine by cos is tan theta. So tan theta is equal to 6 divided by 9, and theta will be equal to tan inverse 6 divided by 9. So if I solve this, so we will get that theta which is required. So theta comes out to be 33.69 degrees, right? And we were also asked to find this F3. So F3, if we use this equation number 2, so then F3, by using this equation, F3 is equal to 6 divided by sine of theta, right? So F3 is equal to 6 divided by sine of 33.69. So we will get the magnitude of F3, which is 10.82 kilonewton, right? And as we know all the components of the magnitudes of all the components of the resultant, so we can find the magnitude of R. So R magnitude will be equal to Rx square plus Ry square plus Rz square, and we will take the square root, right? So Rx magnitude is minus 7, so minus 7 whole square. Ry is minus 5, so we will write minus 5 whole square, and the z component is 6 kilonewton, so I will write plus 6 whole square, so we will take square root, so we will get that resultant magnitude. So let me solve it. So this comes out to be 10.49 kilo.